the Chief Engineer in Training.
I'm Brian. I'm the in-training project manager for the ESA Rocket Project. Today we're going to go a little bit into our background and then talk a little bit more in detail about our goals and some of the progress we've made over the last quarter and a half or so. And then also talk about our team structure and budget a little bit. So we can definitely see that the space industry is growing. In the last decade or so, new companies have opened up like SpaceX, Blue Origin, Vector Launch, and all the major ones are hiring engineers like crazy. A lot of us on the team have a pretty big desire to work for companies like that. So we just want to gain some more marketable skills and also apply some of the coursework that we've learned in a real-life project. With those motivations in mind, we decided to pursue a liquid bipropellant rocket engine. We're one of just a few dozen teams in the US doing so. There are plenty of other universities that have teams or have rocket teams, but in general they design solid rocket motors, which are a lot easier. We decided to choose a liquid rocket engine because it's the industry standard, and we wanted the challenge, and we think that we can do it. So our focus right now is surrounding two main goals. We want to conduct a static test fire of our existing engine, and also we want to become the first university team to launch a rocket into space. Concerning that second goal, we are actually involved in a competition put on by a company called Base 11 that has a $1 million prize purse, and the launch windows for that are spanned across the majority of 2021. So previously, our team has actually gone through the entire process from conceptual design to actually manufacturing an engine designed to propel a rocket to 45,000 feet. And also the surrounding supporting structure with that. So our data acquisition system, plumbing, load-bearing system for testing. So with that first goal, conducting the static test fire of our engine, it's broken up into three main components. We have our engine, our test stand, and our data acquisition system. So right now we're currently in the manufacturing stage with a lot of those components, or purchasing stage, and moving on into the testing. It's been pretty challenging because anything that goes wrong with these tests means an explosion, right? So it's taken a little bit more time to go through all the procedures and create thorough procedures because we keep noticing things that are wrong, keep noticing things that need to change, that we need to make sure are correct and safe. So, but we are making progress. With our longer-term goal of the Base 11 launch, we have a few deliverables that need to be met to stay involved in the competition. The next one that's coming up is our Phase 1 preliminary design report. It's a somewhat in-depth review of all our major subsystems. And the report has about 15 to 20 categories, including things like aerostructures, injector design, combustion chamber design, safety, ground operations. It's probably going to be like a 300-page report. It's a very challenging and difficult deadline to meet, and a lot of those subsystems will have to be developed from scratch. But our previous experience with the current engine that we're working on is helpful because some of those subsystems can either just be transferred over or just scaled up. All right, so this is a quick overview of our timeline. We did have to modify, like I said, some of our testing and manufacturing deadlines from last quarter. The important milestones are highlighted on the second column right here. So our Phase 1 report, static fire, and Phase 2 design entry, which is starting right after that. And those purple highlighted columns are columns where those milestones need to be met. And we try to make it so that no other sub-teams have anything to do that week, since it's such an important time. Within our sub-teams, everything's kind of broken up between manufacturing, verification, and testing. So this is how our team is broken up a little bit. We have our advisors up at the top, Professor Walter and Professor Mies. And then the project managers. Rashid is the current project manager. He's leaving at the end of the quarter, so I'm training to take over. The project managers generally try to stay away from the more technical side of things. That's why they handle mostly like timeline, admin, presentations, stuff like that. That's why they're directly involved with the operations, on the operations side of things, where it's handle the purchasing, catalog, data management, those sorts of things. And then for the technical side, the chief engineers directly report to the project managers. The chief engineers are responsible for making sure that all the sub-teams can successfully complete their goals in a timely manner and have all the resources that they need to be able to do so. And then our sub-teams are broken up into structures, avionics, and propulsion. And we try to have about 2 leads on each team. Personally, I don't like to have a lead ratio higher than like 1 to 5. I think once a lead starts managing more than 5 people, it becomes a little bit chaotic. Although we're having trouble filling that spot with avionics. And then we are also currently in the process of recruiting pretty heavily for the Base 11 competition because it's such a large and difficult design, and we'll likely be adding more sub-teams like launch operations or safety to deal with that, because currently safety is involved in our operations sub-team. All right, I'm going to hand it over to Srinath right now, and he's going to talk a little bit more about our technical progress.
So our avionics sub-team for this quarter has been essentially just verifying and testing all our software and hardware. So on the software side, they created a LabVIEW VI that controls all the actuators, such as our valves and pressure regulators, and also takes in all the sensor data and processes it. So everything from our pressure transducers, our thermocouples, and it basically just puts it all into a neat and user-friendly user interface. And it also contains contingencies, so in case anything goes wrong in the system and that the sensors can detect, it'll shut off the valves accordingly. And that's all being coded and implemented currently. And on the hardware side, all our sensors this quarter had been verified for accurate and timely readings. Same with our valves, just making sure that they actuate when the signal is sent. And same thing with the pressure transducers, just making sure that it can ramp accordingly, so we don't just turn it up all the way, so we can ramp it and just make sure our system doesn't fail. So on the back to the software side, they're still working through contingency plans, just seeing all the different failure modes that can occur with either our cryo systems, our pressurant systems, if anything happens in our injector. So just making sure we account for all the contingencies and making sure that, depending on each contingency, that we plan accordingly how to shut off which valves. Our propulsion team has been focused on taking our design from the previous quarters and moving it towards the manufacturing phase. So early this quarter, we just made sure that all our manufacturing processes for each of our components was finalized, and making sure we find a good vendor to manufacture our parts. So working from top down. For our injector assembly, we had that manufactured by Xometry over winter break, and we received it early this quarter. And that is being currently sent out for manufacturing our orifice holes, which are like little tiny, on the order of like 20 thou holes that will be EDM'd by die molding Corona. Moving down, our combustion chamber is being manufactured in the physical sciences machine shop, basically just cutting everything to size and making sure that we have all our interfaces correctly machined to the right tolerances. Also being sent out this week are our mounting flanges for both the nozzle and the injector, and these will be water jetted by a local company, and they're being made out of combination of steel, aluminum, and arsenolic. And then finally, our nozzle had been manufactured last week, or not last week, last year by a previous project. So that's been ready. So in a week or two time, depending on manufacturing lead times, we'll have everything ready for assembly. And finally, our biggest endeavor was the test stand, which had been designed and analyzed up until last quarter. So this quarter was mainly focused on making sure we have all our parts in and making sure that our assembly is neat and friendly. So the I-beam shown here is actually at our test site in the Mojave Desert and planted in the ground by friends at Amateur Rocketry who run the test site. So we created our own mock I-beam out of wood just so that we can, in the lab, verify our assembly procedures and verify that everything is where it's supposed to be. So the team's been developing assembly procedures and re-verifying them and making sure that all these parts fit accordingly, and so that when we go out in the desert next quarter, that everything is, we know exactly when everything is being screwed in, bolted in, and where everything is at all times. The team has also been working on testing procedures for our various tests, all the way from our pressure test, our water test, our cryo test, all the way up to our static test fire. And so they've been working on we're just re-verifying all the procedures and everything.
All right, and I'll just cap it off with a little bit about our budget. So this was the projected budget that we had at the beginning of the fall quarter. You can see about 75% or so is dedicated to actual design and manufacturing of our components for each sub-team, and then about a quarter is dedicated to tests. Because we haven't actually done any tests yet, we haven't used any of that. So here's what we have actually spent. You can see that we've actually already hit our projected amount for our propulsion sub-team. However, the biggest costs related to that are in manufacturing, and we have pretty much gotten all of it manufactured already. So there's not a whole lot more cost that is needed for that side. And then everything else, we're about halfway, so it looks like we're still on target. I forgot in the last one, we had about $14,000 total, and spent about half, a little more than half, and we're a little bit more than halfway through the year, so pretty much on target for that. And that'll do it. So if any of you guys have some questions.